In this video we will look at how we can use the simulator to determine the average moisture content of the lumber in a real-world kiln. First you will enter your real-world kiln setup with the board dimensions. Choose the wood species, the starting moisture content and the dry density. Then enter the dry bulb temperature and the wet bulb temperature that you have in the kiln. It has to be a drying phase, not a conditioning phase. Let's assume 80 degrees dry bulb and 70 degrees wet bulb are the last entering air drying phase temperatures before conditioning. Let's assume a target moisture content just below 12%. Then extend the end time to make sure that we actually get to that moisture content. Don't enable the conditioning phase and start the simulation. Now we will focus on the temperature drop across the load. It is this purple line in the graph and you can see it varies with airflow changes. There are dips in the temperature drop across the load when the fans reverse. So we want to find values that are outside the dips or fan reversals. Let's pause the simulation at this point and where the average moisture content is about 40%. At this point we have a temperature drop of 6.1 and this is specifically for this entering the dry bulb temperature. Note that at a 6.1 degrees Celsius temperature drop the average moisture content is about 40%. Resume the simulation. And you can let it go to for let's say another 10% moisture content units until we get to about 30%. Now you can see I paused it when the dip occurred. This is not a value that we would want to use. So we resume and we pause again. And now it stopped just before the next fan reversal. So at these temperatures, air speed and moisture content of 26.3, we get a temperature drop across the load of 4.7. And so we continue and we gather more data. Write down these numbers and continue until the end. So now we will just let the simulation go. While the simulation is running, I can show you that one more point that we can add to the data we collect is this EMC, the equilibrium moisture content, that we get at these temperatures. If we would reach 8.8% average moisture content, there will be no more evaporation from the lumber. So our temperature drop across the load would be 0. So 8.8% moisture content is and 0 degrees temperature drop is another point we can use. Now we're getting close to 12% moisture content. And the temperature drop across the load at when we reach 12% moisture content is 0.8 degrees. So when we reach that temperature drop in our real-world number kiln we can stop the drying process and check the actual moisture content. We also note 11.84% and 0.8% temperature drop across the load. At this point we have gathered all the data we need. So in the simplest case we can choose to dry until we reach a 0.8 degrees Celsius temperature drop. But if we are interested to know the current moisture content in the real-world kiln, then we can plot the data we collected. I have already plotted the data from 50% moisture content, about 40%, 27%, 20%, here I forgot to add the temperature drop at 12% moisture content. But I did add this theoretical point of 8.8% EMC where we should get a 0-degree temperature drop across the load. So for this particular dry and wet bulb we can look up the current real temperature drop across the load that in the kiln and then estimate the average moisture content of the lumber. And that is how you estimate the average moisture content of the load. However, it is not possible to determine the standard deviation of the moisture content, but it will help to determine whether you have reached a certain critical moisture content or when to end the drying process.